everybody, this is Ms. Canair. Today we are talking about the special cases of factoring. So this is really talking and looking at a couple of special scenarios that might happen when we're factoring, and these are kind of the shortcuts that we're going to use to figure them out. So before we begin, I want you to pause the video right now and I want you to review how to factor by grouping. So pause the video for 5 minutes or so right now and review this problem. All right, hopefully it came back to you pretty easily, but let's just run through it really quick to make sure you remember factor by grouping. So I'm going to look at I'm going to find the greatest common factor between the first two terms. And hopefully after looking at it, you are easily able to see that the greatest common factor is 3x squared. So after I factor out a 3x squared, all I'll have left is 8x minus 3. Excellent. So then what I'm going to do, remember carry down the sign, is then I'm going to find the greatest common factor between these last two terms. And hopefully, after looking at it, you are easily able to see that it is a 5. That 5 is the greatest common factor between those two terms. So if I factor out a 5, you are left with 8x minus 3. Remember to see if we did factor by grouping correctly. What I'm going to do is I'm going to see if my parentheses match. And if you look at that, our parentheses match. So what I'm going to do is I'm going to factor out one of them. Oops, that should be 8x minus 3. And then, in front of that, I'm just going to write what I have left. And I've got 3x plus 5, so 3x squared plus 5. There we go. That is how you factor by grouping. So just a little recap of what we've already done. So, today we are talking about a couple different special cases that can happen. And one of them is called the difference of two squares. So this would look like something like this up here. So if we have a difference of two squares, remember difference means subtraction, so they have to be being subtracted, we can write it, it can be factored to look something like this. So remember, before we actually get into this, we have to talk about what are perfect squares. What are these squares that we're talking about? Perfect squares are numbers that you get when you multiply two of the same numbers together. So for example, if I ask you to list some perfect squares, that would be 25, 49, 81, 100, 121, 144, 169. Those are all perfect squares because this is 5 squared, this is 7 squared, this is 9 squared. Those are perfect squares. So when figuring out whether or not you should use the difference of two squares, this is kind of a little checklist. So remember, the first thing you should do is always check for the greatest common factor. And remember, the second thing is, does it have two terms? And I want you to add in here, are they being subtracted? Because really the only time we can do this is if they're actually being subtracted. And then if so, are they both perfect squares? If so, then we can go ahead and we can do this. So let's dive into this. So here's two examples. For example, example 1, x squared minus 16. So remember, first thing we always do is check for greatest common factor. The only greatest common factor that I can see would be a 1. And remember, in factoring, we don't normally write out the 1s. So that being said, is this a difference of two squares? So if you remember, the number that's out front here is a 1. Are 1 and 16 both perfect squares? I hope you were thinking in your head, absolutely, yes, they are. Which means that we can factor this by the difference of squares. If you remember how this is set up, it looks something like this. So how we're going to figure out what's going to go here is we want to think about factors of 16. A trick that you can use is you can think about, okay, what's the square root of 16? Because if I take the square root of 16, I should get the same number. So the square root of 16 is 4 and 4. The only thing to check for your signs is that if you remember the difference of square, the rule is you always have one positive, one negative. That's just the rule. That's how it works. That is fully factored. We cannot do any more with that. Example 2 is the same sort of thing. First thing you should do is check for the greatest common factor. Is there a greatest common factor? Well, 1. But remember, with 1s, we don't normally write 1s if we're being multiplied or divided. However, I see that I have a coefficient of 1 and my constant is negative 81. I hope that you're able to recognize that those are, in fact, perfect squares. So what's going to go here is going to be the square root of 81, and that's 9, because 9 times 9 will get me my 81, And remember, we just talked about the rule, one has to be positive, one has to be negative. The really, really nice thing about these is that if you don't remember the shortcut at all, you can just carry on and you can factor this like we've been factoring for the last 2 weeks. So when I say that, I mean you can treat this as x squared plus 0x minus 16. Remember, we can really add a 0 and it's not going to change the meaning of anything. So then we take a look, okay, what are my factors of 16 that add to 0? So my factors of 16, if I were going to label them, would be 1 and 16, 2 and 8, 4 and 4. Okay, well I see I have 4 and 4. And if I do plus 4 minus 4, I will get the 0 that I want. So my factors would be x plus 4, x minus 4, which if you look back up here, that's exactly the same thing that we got in the beginning. So this is really just a shortcut to save you from all of this other stuff right here. Alright, let's take a look at what we have next. Alright, a couple more examples. So remember, the first thing you should do is you should take a look and see if there is a greatest common factor. So in number 3, I hope that you can see that 25 is the greatest common factor between these two. So if I factor out a 25, I would be left with x squared minus 4. Okay? It would be really nice for us to say, alright, we're done, we can move on to the next problem. However, we're not. So remember, we are looking for the difference of squares, and there is a 1 out here. Are 1 and 4 perfect squares? I hope that you are thinking, yes, they are. Which means that this can be factored more. So, x and x, I bring down my 25, because if I forget to copy it, it changes the meaning of the whole entire problem. So, we've got this 4. And remember I said the trick to figure out what's going to go in these last 2 spots is taking the square root of 4, and that would be 2. And 2, the rule is always 1 plus, 1 negative. Does not matter which one, if you want to do the plus first or the minus first, doesn't matter. And we are fully factored. Take a second and pause it if you need to write that down. Otherwise, let's move on to example 4. So again, remember the trick. Always look for the greatest common factor first. If I can simplify numbers and make numbers smaller for me in math, I feel like that's probably the best bet. So if you look at 12 and 27, I hope you're able to see that 3 is actually the greatest common factor between those two. If I factor out a 3, you're left with 4x squared minus 9. Alright, it would be nice for us to say, yeah, I'm done, that's nice, we're done. However, if you are able to see that 4 and 9 are both perfect squares. So this one's a little bit tricky because this is not just a 1 now. This is actually a 4. But it's treated exactly the same way. So I know I need 2 sets of parentheses. I know one has to be plus and one has to be minus. And I cannot forget to bring down my 3. Okay, so now we have to figure out what's going to go in these 4 spots that we have left. So remember, the trick for this one is we took the square root of the last number, so the square root of 9 is 3, so that's what's going to go here. And then you want to think about what number, if I multiply it by itself, will get me 4x. So don't think about it too hard, but if I do 2x and 2x, I would get back my 4x squared. That is it. That is fully factored. We cannot do anything more than with that. That is as far as that is going to go. So pause it if you need to copy anything else down. We have 2 more examples left. So, example 5. Actually, what you should do is you should pause this video for a couple minutes and try these last 2 on your own to see if you are grasping this concept of difference of squares. So pause the video right now. Alright, let's take a look and see how you did. So, we have 18x to the third minus 50x. So, we have to think about common factors. So the common factors between 18 and 50. And it looks kind of weird. So let's take a look here. So, greatest common factor between 18 and 50. I believe the greatest common factor is actually only 2. And I notice that they both have an x, so I'm also going to pull out an x. So if I do that, I'm left with 9x squared minus 25. Alright. So then what you should do is you should say, okay, let's see, are they a difference of squares? Are 9 and 25 both perfect squares? And in fact, they are. So what I'm going to do is I'm going to bring down my 2x and write my 2 sets of parentheses. I know one has to be plus, one has to be minus. So remember the trick to find out what goes in the last one is I always took the square root of the last number. In this problem, it is 5. So I have 1 plus, 1 minus 5. Alright, so second part is take a look at this 9x squared. So I need a number that I can multiply by itself to get 9x squared. And that is in fact 3x and 3x. Because 3x times 3x will give me back my 9x squared. That is fully factored. We are done. Alright, and then on to example 6, we have x squared minus 1. This is in fact the difference of squares because they are both 1. So this would be x minus 1 and x plus 1. That completes the notes for difference of squares. Stay tuned for the next video, and that will talk about perfect square trinomials. Thanks, guys.